In example 1, we're taking a look at this rectangular frame here, and we see that a woodworker has a frame that has a JK that's equal to 50 centimeters, and JL, that's our diagonal all the way across here, is equal to 86 centimeters. So we're asked to find the measure of KM, LM, HM, and JM. So let's take a look here and see KM. KM is the other diagonal, and we know that the properties of a rectangle say that the diagonals are congruent, so KM must be equal to 86 as well. Next one says LM, and we know that the properties of a rectangle say that opposite sides are congruent to each other, so LM and KJ must be equal to each other, so LM is 50. And then HM we see is half of our diagonal here. Remember, the properties of a rectangle say that the diagonals bisect each other, so 86 is going to be cut in half, and when we take 86 and divide that in half, we get 43. So HM is equal to 43. Now our final one asks us to find the length of JM. So the length of JM here is our other side of this rectangle. Now if I take my rectangle and I trace along these two edges and then come across my diagonal, what I'll keep in mind here is that this is a right triangle. So I'm just going to pull this red right triangle out. We know two of the measurements of this red right triangle. The side here on the left is 50. The hypotenuse of this right triangle is the diagonal of this rectangle, and that's equal to 86. And then finally the side that we want to find, which is JM here, is the missing side. So we're going to use Pythagorean theorem. We're going to set up Pythagorean theorem here to solve for the value of that side JM. In our next example, we're going to take a look at WXTV, and we see that it is a rhombus. Now, a rhombus, remember by its properties, know that all four sides are congruent to each other. Let's start off by finding the value of B and finding the length of side TV. We know opposite sides here are congruent to each other. In fact, all sides are congruent, so we're going to write the equation 3B plus 4 is equal to 13B minus 9. B is equal to 1.3. Now we can use the value of B to substitute that back in to find the length of side WV, which will be equal to the length of side TV. When we substitute that back in, we will get 13 times 1.3 minus 9, which is equal to So let's take a look here. We know that 14a plus 20 is equal to 90 degrees. So we'll write the expression and solve for a. Now, once we find our value of a to be 5, we can take that a and substitute it back into our expression for this part of my angle. But keep in mind, I want to find angle VTZ. Now, that's this angle here, but remember, our diagonals bisect these angles. So if I find 5a minus 5, I will find the other angle VTZ as well. So I'm going to substitute 5 in for a, and I come up with 25 minus 5, which is 20 degrees. So the measure of angle VTZ is 20 degrees. All right, in our final example for today, we're taking a look at this proof, and we're asked to prove that triangle ABE is congruent to CDF. So A to B down to E, this guy up here in the top right-hand corner, has got to be congruent to F to D to C. Well, that means we need to be able to fit it into one of our triangle congruency conditions. We know that ABCD is a rhombus. So we're going to start off by listing our given information. Now, from that given information, we know that a rhombus has all congruent sides. So I'm going to go ahead and mark that side AB is congruent to DC, and that will be my next statement. And we can claim this by the definition of a rhombus. Now, my next thing I want to do is I want to state that there is an angle that's congruent, because I'll not be able to fit it into that side angle side congruency. Well, I also know that a rhombus is a parallelogram, and by definition, I know that the opposite angles of a parallelogram are congruent to each other. So I can say angle D is congruent to angle B, because the parallelogram implies opposite angles are congruent. Finally, I've gotten to fit this into a side angle side triangle congruency statement, so my next step will be to say that triangle ABE is congruent to triangle CDF by the side angle side triangle congruency theorem.